The solutions we're doing right now are from page 180 to 181, 113 in our textbook. This is section 5.3, dealing with special segments and angles that are formed when we have parallel lines. Now, theorems involving parallel lines seems a little out of place here, but it's all tied into parallelograms and quadrilaterals. So first we're going to start, these first couple problems say that A, B, E, and F, A, B, E, and F are midpoints of these things here. So I'm just going to label these two congruent, these two congruent, this guy is equal to this guy, and that one's equal to that one. First question says if CD is 24, then AB equals what? Well, if we look at this triangle here, we said if we connect the midpoints of the sides of two sides of a triangle, that length right there will be half as long as the side that it's parallel to, right here. So AB is gonna end up being 12. And EF, if you look at this triangle here, YDC, we also have EF is connecting the midpoints of the sides, so it's also half of 24. So that'll also be 12. Okay. Next one says if AB is K, what's CD? Well, CD will be twice as long, we said, so it's 2K. And EF will be half as long as CD, so that's also K. Next one says if AB is 5x minus 8, and EF is 3x, then what's x going to be? Well, we said that both of them are half of CD, so they're equal to each other. 5x minus 8 equals 3x. So we subtract 3x from both sides and add 8, and we get x is 4. All right, take those away. Next, we have CD is 8x, and AB is 3x plus 2. And we know that AB should be half of CD. So we have a choice here. You can say 2 times the quantity of AB equals 8x. Or what I would do is I would say 3x plus 2 equals half of 8x, which is 4x. Subtract 3x from both sides and you get x is 2. The next one says, number 5, we have given L, M, N are midpoints of the sides of this triangle. So here's a midpoint, and a midpoint. I think it's very important that we always label diagrams if we can. So triangle TKO, we want to find the perimeter of each. Well, here, if this piece here is 7, then OK is going to be twice that length because NL is connecting midpoints of the sides of the triangle. So it's not only parallel to OK, it's half its length. So OK, the whole thing is 14, and since this is M is a midpoint, these are each 7. And M here is 8, so this up here is 16, which is 8 and 8. Let me write that a little neater. And since this piece is 5, you can probably guess that this whole length is 10. And since N is a midpoint, it's 5 and 5. So when we're asked to find the perimeter of each figure, TKO, we just add 10, 16, and 14. 10 plus 16 plus 14, and we get 30, 40 for letter A. Next it asks for LMK. LMK. Well, the perimeter of this is just 7 plus 8 plus 5, so that's 20. Next, quadrilateral or parallelogram TNML. TNML, we just add 5 plus 8 plus 5 plus 8. 16 plus 10 is 26. And quadrilateral LNOK. LNOK. So we have 7, 5, 7, and 7 is 14. and then the last side is 8. These are the sides here. So we have 7 and 8 is 15, plus 5 more is 20, plus 14 is 34. That's how we do that one. 6 says name all triangles congruent to triangle TNL. Well, since its sides are 5, 8, and 7, any triangle with sides 5, 8, and 7 is congruent to this triangle. So there's actually going to be a bunch here. I would say triangle L, but we have to make sure when we say TNL, we go in the correct order when naming these. So the triangles that I would name here would be triangle, I'll start here with NOM, starting with the side, the 5 side, NOM. I would also say triangle LMK, and triangle MLN are all congruent to that one. So this triangle, and this triangle are all congruent to this triangle here. Let me clear some of that gunk away. Next it says, suppose you're told that the area of triangle NLM, this middle triangle, is 17 and 3200 centimeters squared. What is the area? That's a typo. That should say area of triangle TKO. Well, TKO is this whole big triangle here. Now, since we just got done in the last one saying that all 4 of these triangles are congruent, we know since this one's 17.32, so will there be this one, and this one. So we just take the 17 and 32 hundredths and multiply by 4. And using the power of technology and incredible brain power, we say it's 69 and 28 hundredths centimeters squared. All right, 7, 8, and 9 ask you to name all points shown that must be midpoints at the sides of a triangle. So obviously right here we have x and x, so D must be a midpoint of the side of a triangle. Here we have y and y, so these two are equal, so E is a midpoint of the triangle. But over here we have z and z plus 1. Obviously those are different lengths, so z is not a midpoint of the triangle. This one, D is a midpoint. And since it's parallel here, now this is where it gets a little trickier. See, these arrows indicate that this is parallel, so it must also hit the midpoint of this side over here. So E is also a midpoint. And this one, F is given to be a midpoint. And since we're running parallel from F, we're going to hit the midpoint of the other side. So D is also a midpoint. What we're really going for is the theorem that says if we start on the midpoint of one side of the triangle and run parallel to the other side here, then we have to hit a midpoint over here. Next, number 10. Now we've got some parallel lines here, and for these, the directions give you that you have parallel lines, and it also tells you that EF, FG, and GH are all congruent. So these 3 lengths are the same. So it says if AB is 5, what's AD? Well, if AB is 5, these are all 5, so AD is 15. If AC is 12, let's clear these away now. If AC is 12, which would make these two congruent, which is 6 and 6, then CD has to be 6. Next, these are pretty easy. If AB is 5x and BC is 2x plus 12, well, we know that those things have to be equal. So we say 3x equals 12, x must be 4. Next, if AC, now notice AC is the length of 2 of these buggers, what we're really finding out is that all these have to be equal to each other, right, the whole time. So AC is from here to here, so it's twice as big as the one segment there. It's 22 minus x. And BD, which is also two of those buggers, so that's going to be equal to that, is 3x minus 22. What's x have to be? Well, we add x to both sides, and add 22 to both sides, and we get x equals 11. Okay. Next, we say if AB is 15, and BC is 2x minus y, and CD is x plus y. Oh my. Then x and y must be equal to what and what? Well, here, we know both of these things are equal to 15, so we say 2x minus y equals 15, and x plus y equals 15, because they all have to be equal. Now what we see here is we have opposite coefficients for the y, so we're going to use the elimination method, add these together, and we get x is 10. And if x is 10, y must be, because x plus y equals 15, if we put 10 in for x, we know y must be 5. Okay. Next, we have if, oh, let me clear this off. Next one we have, actually we're going to finish the next one on the next video, because this one's getting kind of lengthy, and then we'll finish them up.